Have you ever really stopped to think about the massive, invisible world that powers our digital lives? Today, we're going to pull back the curtain on that hidden city, the architecture that keeps us all connected. And trust me, you might be surprised by what we find. I mean, really think about it. A giant corporate office, a university campus. You've got thousands of people all streaming, downloading, and video conferencing at the same time. How in the world does it not all just collapse? Well, the secret isn't just about throwing more cables and hardware at the problem. Nope, it's all about an elegant, brilliant design. The best way to get your head around it is to imagine a large network not as a tangle of wires, but as a sprawling, super efficient digital city. And just like any great city, it all has to start with a master plan, a blueprint that makes sure everything can grow and run smoothly without descending into total chaos. This master plan is what we call a hierarchical network design. The whole idea is to build the network in different layers, where each layer has a very specific job to do. A lot like how a city organizes its roads, from tiny side streets to massive freeways. So this three-tier model is actually super intuitive once you see it. At the very bottom, you've got the access layer. Think of these as the local streets right outside your house. It's where your computer, your phone, all your devices actually plug in. Then, in the middle, we have the distribution layer. These are the main roads, the arteries connecting different neighborhoods and collecting all that local traffic. And then at the very top, you have the core layer. This is the big one. This is the high-speed freeway, the backbone of the entire city, built for just one thing, moving huge amounts of data crazy fast. Okay, so we have our city blueprint, our road system is laid out, but a city full of roads is pretty useless without traffic lights and rules of the road, right? That's where our digital traffic cops come in. In our digital city, all those little bits of data are the cars, and we absolutely need traffic cops and signal systems to make sure they get where they're going without, smashing into each other. These are our network devices. Way back in the early days of networking, we had this thing called a hub. Just imagine a simple intersection with no stop signs, no traffic lights, nothing. Any car, any piece of data that came in was just shouted out to every single other car. Total chaos, right? It was incredibly inefficient and led to constant collisions. We call that mess a single collision domain. But then along came the switch, and this was a total game changer. A switch is like a really smart traffic light. When a data packet shows up, the switch looks at its unique hardware ID, its MAC address, which is kind of like a license plate, and sends it only to its specific destination. It doesn't shout at everyone anymore. This was brilliant because it creates a private, collision-free lane for every single connection. The efficiency just skyrocketed. But what if you need to send a package to a whole different city? Well, for that, you need a router. A router is like the massive highway interchange that connects your entire city to other cities. Other networks, like the internet. It makes decisions based on IP addresses, you can think of these as the zip codes of the digital world, to get traffic from one network to a completely different one. All right, so our digital city is growing up. We have roads, we have traffic lights, but that's not enough. We need to start organizing things for better security and, of course, better performance. You know how a real city works. You have the financial district over here, the arts district over there, and residential areas somewhere else. Each zone has its own vibe, its own needs. Well, networks do the exact same thing, but they do it virtually. And this is the magic of a VLAN, or a virtual local area network. It lets you group devices together based on logic, not their physical location. So the entire accounting team can be on their own super secure network, and the sales team on another, even if their computers are all plugged into the very same physical switch. Each VLAN acts like its own walled-off neighborhood, what we call a broadcast domain. So an announcement made in one neighborhood doesn't bother anyone else. It's a huge win for both security and keeping things running fast. So, our city is planned out, the traffic is flowing, our neighborhoods are all neatly organized. But there's a hidden danger. One simple, easy mistake that can bring the entire city to a screeching, catastrophic halt. This is probably one of the most critical questions for any network engineer because, you want backup roads in case there's an accident, but you have to be so careful about how you build them. And the answer is, you must never, ever create a loop without a system to manage it. If you just connect switches in a big circle, a single broadcast message, like a car asking for directions, gets trapped in an infinite loop. It gets copied and resent over and over and over, amplifying itself until it creates what's called a broadcast storm. This is the network version of total citywide gridlock. Literally nothing can get through. The whole city just freezes. So how do we get those critical backup paths without causing a complete meltdown? The answer is an amazing piece of tech called the Spanning Tree Protocol, or STP. Think of it like the network's own automatic GPS. It looks at all the possible roads and intelligently blocks any redundant ones, making sure there's only one active path at any time. But if that main road suddenly fails, bam, STP instantly unblocks the backup path and keeps traffic moving without missing a beat. Now, the original STP was awesome, but it was kind of slow. Rerouting could take 30, even 50 seconds. I mean, that's an eternity in the digital world. It was like pulling out a paper map to find a detour. Modern versions, like Rapid VSPT Plus, are unbelievably fast. We're talking about switching over in less than a second. It's literally the difference between that old paper map and an instant GPS update. And for today's networks that have to be always on, that's absolutely essential. Okay, we've prevented gridlock. That's huge. Now, how do we crank things up a notch? How do we increase the capacity of our busiest roads and make our city's infrastructure even more powerful? Well, there are two fantastic ways we do this. First up is Ether channel. The best way to think of this is bonding several parallel roads together to create one massive superhighway. You're literally combining the speed of multiple physical connections into one logical one. It's a huge bandwidth boost. And second is switch stacking. This is like merging all the individual traffic control centers into one single unified command tower, which lets you manage a whole bunch of physical switches as if they were just one big, powerful device. So let's just quickly recap the keys to building a strong digital city. You gotta start with that solid blueprint, the hierarchical design. You need smart traffic control with switches and routers. You need to create organized neighborhoods with VLANs. You absolutely have to have an emergency plan like STP to prevent that dreaded gridlock. And finally, you build bigger and faster with high-capacity tools like Ether channel. When you put it all together, you get this incredibly complex yet really elegant system working silently behind the scenes. It's an entire invisible city with its own blueprints, its own traffic laws, and its own emergency services, all working 24/7 to make sure your data gets exactly where it needs to go in an instant. It's pretty amazing when you think about it, isn't it?